Here we are going to study about what is force, and forces are due to the interactions, and we will explore what are the force over here, right? So the what is the force? So we have already force in standard 7, and we can recall it how we can decide whether an object is moving faster than the other. Then what does the distance moved by an object in unit time indicate? So you also know that ground slows down, and sometimes it may possible that the ball may slow down and also changes its direction. Let us consider first a case, or you can say any a football you are having and you are kicking to it. So before kicking, what happens to that football? The football is in the state of rest. That ball will not move from one place to the other place until and unless it is acted upon by an external force. Here we need to apply the force to that object so that that object will change its position from initial position to the final position, right? So what happens in this case? You just see it is written over here that when you kick a ball starts moving, and this means to move a ball you need to apply some amount of force in form of a kick, right? So even to stop a rolling ball you need to apply some amount of force, right? So why that ball stops after rolling towards some certain distance? Because a frictional force is there, so interaction is also there, right? So what exactly the force is? So we can genuinely call it as that opening, sorting, throwing, kicking, lifting, pushing, hitting, pulling, and all these things over here that together in the two basic actions, that is push and pull, right? So what science says? Science says that moreover the interaction of one object with another object result in the force between the two objects, right? So if two person will not be there, if two objects will not be there, then that force cannot be created, and or that push and pull phenomena cannot be happened, right? So in the first picture you can see a person is kicking that football, and in the second picture you can see two peoples are interacting with each other, or two peoples are pulling their rope from the middle portion towards themselves in the opposite direction. So what happens in this case? In this case we are watching that two objects or two persons are interacting with each other so that that force arises, right? So let us go to the next one. We can call that as the force R due to the interaction that we just previously we just have seen that two objects is needed to create that force. So suppose a man is standing behind a stationary car. You can see the first picture over here. This person is standing over here, right? That car is in the stationary state. Car is not moving now. So can you tell me, will the car move due to his presence? He is standing, he is having the distance between the car and the person. There is having a distance. There is a distance. They are not connected with each other. So can you tell me, is there any force arises? No, there is not any force arises because they are not interacting with each other. They are standing in their positions, right? So now if that man begins to push the car, so what will happen to it? So the car may begin to move in the direction of the applied force. See over here in the second picture, this person is pushing that car towards the front direction, right? So what will happen to that car? That car will move from this position to this position. We can say the car will starts moving from the state of rest, yes or no? So over here we are noticing that man has to push the car and to make it move. So finally what we got to know that at least two objects must interact for a force to come into the play, right? So that's the interaction of one object resulting in a force between the two objects, okay? So now we are going to explore what the force is, right? So now you see there is a box, and box is having some mass and two peoples are coming, and the two peoples are pushing it to the certain direction. The direction can be any direction, but both are pushing in the same direction. So what will happen to that box? That box will move from one place to the another place, because two objects are interacting with each other over here. Box and the two peoples, they're interacting with each other. That's why that force will arise, right? So that object or that box will transfer from one position to the another position, right? So what happen if the two person will push the same box but in the opposite direction, right? And they are having the equal magnitude of force. Equal magnitude of force means having some numerical value. That means they are pushing in a certain magnitudes. Like the first one pushing that box into the magnitude, and the second one is also pushing, is having some magnitude. So what will happen to their case? There are two things or three things are coming in this case. The first case, if the first person or who is standing in the left side, if he is pushing the box in a higher magnitude than the second person, then that box will move towards the second person, right? If the second person will push that box in a higher magnitude than the first person, then that box will move towards the first person. So what we got to know over here, the higher magnitude is applied in the certain direction in comparison to other. So the position of the object will change according to the higher magnitude. That means force applied on the object in the same direction that added to one another. In the first case we have discussed that two persons are pushing that box to the certain direction. That's why that box will move in the certain direction in the single direction. But in the second case, two persons pushing that box against each other, or we can say in the opposite direction. So what will happen in this case? In this case, we can calculate their force by taking the subtraction among them, right? So if the two forces act in the opposite direction on an object, and the net between the two forces, right? So if the first person is applying, let's say I will be telling you the unit of the force is called as the Newton. Like we are measuring something, we are telling that it is 5 kg. That 5 kg is nothing but the kg is the unit of that weight. Yes or no? Weight or mass, we can say. That box is having some mass. Let its mass. If I will tell the force, then in that case, what will happen? The unit is used, that is called as the Newton. That is the higher unit, and there is a smaller unit is also there, or lower unit is there, that is called as dyne. That is 10 to the power 5 dyne. That will read it in the higher class, but in your standard it has some unit that you will read later. But to make you understand this situation, we will be getting that, right? So in the second figure we are saying if the first person is pushing that box in 5 Newton, that first person is having the force 5 Newton he is applying, and the second person is applying 3 Newton of force to that box. So what will happen? So towards whom that box will move? That box will move towards the person B. Why? Because the person B is applying less force in comparison to the first person, right? That is the reason why I told you that. So in the direction to which the magnitude of the force is higher, that will move towards that certain direction, right? So if the two forces act on the opposite direction on an object, so what is the net force? So what is the net force acting on that box? So always you keep in your mind that the net force is always the difference between their two forces. So I told you in the first case that first person is applying 5 Newton of force and second person is applying 3 Newton of force. So what is their difference? The difference is 2 Newton, right? So the net force is 2 Newton on it. Now you think the third phenomena that I was telling, the third phenomena where the first person is applying 5 Newton of force to that box and the second person is applying 5 Newton. We are seeing that the two persons are having the same magnitude, right? So what will happen in this case? that box will not move from body. Why? Because here both the magnitude are same and it is in the opposite direction, right? If it is in the unit direction, then it is the different case. If it is in the opposite direction, it is applied from the opposite direction, in that case it is different, right? So if they are pushing that box against each other, we can say they are putting that force in the opposite to each other. In that case, if they are putting the equal amount of or equal magnitude of force to that object, then that object will not move towards anywhere. That will be in the state of rest, and their net force acting on it will be always the difference between the two forces. So 5 Newton minus 5 Newton is 0. Now go next to the next slide. Over here you can see I have written that a force could be larger or smaller than other or equal to each other. We know that all are having the different forces to apply, and all the different phenomena will create their own force according to the situation, right? So force cannot be equal, that can be different, that can be same. We cannot say that it is same in all the case, right? So force could be larger or smaller than the other or equal to each other. That we were discussing, that three phenomena, and the strength of that is usually expressed by its magnitude. That I was telling, magnitude is nothing but the numerical value of that, right? So also if the direction of the magnitude of the applied force changes, its effects also changes. Yes, obviously. Here it is written that if the direction of or magnitude of the applied force changes, that I was telling, that in the previous case, you see, if the two persons will apply the force to that box in the certain direction, in the unit direction, in that case the situation is something different. Here in this case, box will move towards the front or moves towards the certain direction wherever they are putting the force, right? But in this case the direction is different, right? The direction is different, their magnitude can be different or their magnitude can be same, right? So that is why it is written that if the direction of the magnitude of the applied force changes, its often effects also changes. Okay, so now we have came across all these things. So finally we will also access ourselves how much we have understood, right? So we cannot go blindly, so we will go to the test. You can get the test link over here. You can get the test link over here, or you can access yourself. Let us check this out. Your link is will be provided in the description box. You can check it, or you can go through the test how much you have understood in this chapter, right?